Hello everyone, Dr. Chips here and welcome to this catch-up computing lesson. The aim here is simple: recap some computing we might have forgotten during lockdown and catch up on another subject at the same time. So today I have for you infinite times tables. We're going to code a simple program in Scratch that'll keep asking you times table questions over and over and over and over. You get the picture. Who's the quickest with their times tables facts? Let's find out. So first up, we need an algorithm. So get ready to pause me and talk to the person next to you or to yourself. What are the precise steps in the algorithm for a quiz which asks times table questions over and over? Imagine you are the program. What do you do when you ask times table questions? So you think of two numbers, you ask the question, etc., etc. I want you to have a discussion and then try jotting down the algorithm on paper. Once you're done, unpause me and we can see how your algorithm compares to mine. Okay, over to you. Pause me in 3, 2, 1. Excellent, well done everyone. So, how does your algorithm compare to mine? And remember, they don't have to be exactly the same as we write our algorithm in whatever form suits us. But let's see if you've got the same key steps. So you can see with mine that step 1 was to generate two numbers between 1 and 12 for our question. Step 2 is to ask the question by saying what is the first number times the second number. Step 3 is to check if the player's answer matches the correct answer. Step 4 is to say well done if they're correct and incorrect if they're incorrect. And then step 5 is just to go back to step 1 and repeat over and over and over. Let's not get into that again. Now, one of the key computing concepts I want to recap with you today are variables. Now, you might remember that a variable is one way of storing and using a piece of information in a program. So, for example, you might use variables to store the value of lives or score if you're coding a game, or the values which sensors are giving, like the ultrasonic sensor, which I use with crumbles. I'll do some videos on that another time. So I've purposely chosen this activity today because it's going to require us to use variables. So, next task. I want you to look at your or mine algorithms and think to yourself, what are we going to need variables for in this program? Now, a trick here which I always tell my pupils is to think about what's going to be changing when the program is run. Because for everything that's going to be changing in values, we're going to need a variable. So I'll help you out with the first one. I think we'll need a variable for first number, as this is going to be different each time the program asks a question. So over to you, have a think. What other variables are we going to need to turn this algorithm into code in Scratch? Pause me in 3, 2, 1. Welcome back, people. So let's see how you did. Now, when I look at that algorithm, the things I think we're going to need variables for, because they're going to change as the program is run, is first number. I said that one already. Second number. Player's answer and correct answer. Now, the player's answer one is a bit different in Scratch, and I'll show you what I mean about that in a minute. Okay, so now we've got our algorithm and we've given a little thought to the variables we might need. I think it's time we code this. Time to beam me into Scratch. Okay, so our first job is to create those variables we've just decided that we need for our program. I'm going to show you how to make one variable in Scratch, and then I want you to pause me, not just yet, but then pause me and create the other variables that we need as well. So really easy to create a variable in Scratch. On the left-hand side, we go to where it says variables, and then we click make a variable. Now we have to give our variable a name, and it's really important we give it a sensible name which relates to the information it's storing. Otherwise, it makes it really difficult to work with that variable within our code if we don't know what's in that variable. So, first variable that we said we would need is for the first number in our multiplication question. So, I'm going to call this one first number. Nice, sensible name. I'll click OK, and you can see there it's now created this variable called first number. So I want you to create a variable for first number, second number, which was the second part of our multiplication question, and for correct answer. We don't need to worry about a variable for the player's answer because we're actually going to use this variable here called answer, which is a predefined variable which loads up in Scratch. Okay, over to you. Pause me, and once you are done creating those three variables, unpause me again and we'll crack on with the next step. Okay, awesome job everyone. We've now got the three variables that we are going to need, and we've got that answer variable which has already been predefined in Scratch for us. One thing I forgot to mention is that once you've created your correct answer variable, just click on that tick there so it doesn't display it on the stage. Otherwise the player could just look at what the correct answer is and cheat. And we don't want that. So, okay, next step is to implement the first step of our algorithm, which was that we wanted to generate two numbers between 1 and 12. So each time we ask a new question, we want to generate two random numbers between 1 and 12, which is going to make up our multiplication question. Now, I'm not going to show you exactly how to code this. I'm going to show you the blocks I think you will need, and then I'm going to ask you to pause me and have a go at combining them. So here we go. These are the blocks I think you will need. We'll start our program when we click on the green flag. And then we might want to use a couple of these set variable to blocks, and you can drop down menu here. So remember, which variable is it that we want to be setting to these two numbers? I think it might be first number. A little bit of a hint there for you. And within the operators, there is this block which allows us to pick a random number, and you can vary where that picks a random number between. So over to you. Have a go at using those blocks to implement that first step in our algorithm. And if you need any help, unpause me and I'll show you how I did it. Okay, so this is how I combined those blocks of code so that when the program is run, it sets the first number, that variable, to a random number between 1 and 12, and it sets the second number to a random number between 1 and 12 as well. So you can see I tested it there and it set them to 6 and 12. Let's run it again, 3 and 5 this time. 3 and 7. So then we're going to use those two numbers to form our multiplication question. And in fact, on our algorithm, our next step was to ask the question. But before we do that, I'm actually going to get you to add another line of code in here which sets the correct answer, because we're going to need that correct answer to check whether or not the player's answer is correct. So let me show you how we can do that. We can again go to variables, and we're going to again go to set, and we are going to set the correct answer to, well, what is the correct answer going to be? The correct answer is going to be the first number multiplied by the second number, and that's going to change every time, but that's okay because we can actually get our program to do the maths each time using one of the operators. So we can say that we're going to set the correct answer to whatever our first number is times our second number. So now when I run this, the first number this time was set to 11, second number was set to 6, so we know that the answer should be 66. If I quickly just tick on here to see what is being held in our correct answer variable, it is 66. There we go. So now we are all set then to ask the player the question and check whether or not the answer that they give is correct or not. So before we do that, pause me now, add this line of code to your programs. See you in a second. Brilliant. Okay, right. So next step, but before we do, make sure you untick the correct answer variable again, so there can't be any cheating. Now, next step in the variable was to ask the player the question, and this is going to require a clever bit of coding, because what we need the program to do is actually generate this question each time based on the values we have in our variables first number and second number. So for the example I've got running here, it needs to say what is 11 times 6. Now again, I'm not going to show you exactly how to do this. I'm going to show you a couple of blocks of code which I think will help you achieve this. Then I'm going to give you time to try and work out how to do it yourself. So let me show you. We are going to use from the sensing the ask and wait block. But what we are going to maybe explore and use as well is that within operators you can use this join command here, and you can pop that into there, and you can pop another join into a join, and then you can pop another join which is in a join which is in a join. And what this does is allows you to split up the string of text which will be presented when this block is run. So if I just show you what I mean by that, if I just put in here some numbers 1, 2, 3, 4, and I run this time, it will say 1, 2, 3, 4 because that's what I've got in here. But we can also use it to display whatever's in a variable, for example. So here it's 1, 9 because it's set the first number to 9, 3, 4. So maybe we could get it to say what's first number times, I've given away too much already. Pause me now and have a go at using the ask and join blocks with your variable so that when our program is now run, it will ask the player the question for the two numbers which are being stored in the variables. And if you need any extra help, as always, unpause me again and I'll talk you through how I went about coding it. Okay, so for anyone that needs a little bit of extra help, let me show you how I did it. You actually needed a join inside a join inside a join inside a join, because by having those 4 joins, it gives you 4 spaces to put what is first number times second number question. So now let's test it. When I run my code, it's going to set the first number to a random number between 1 and 12, do the same for the second number. Then it's going to ask the question using those 2 numbers. Here we go. Hope it works. There we go. Yeah, so that one, what is 3 times 11? And because we've used that ask block, it displays this box on the stage where the player can respond. And when they hit enter, it stores their response in that answer variable, which I mentioned before, which is here. So when I click on the tick or I hit return, 33 is now being stored as their answer. Okay, time for a recap, folks. Let's see how we're doing with our algorithm. So far, we've got our program to generate 2 numbers, and we've got it to ask the question. Next, we need to check if the answer that the player gives is correct or not, and then say either that's incorrect or well done. Easy stuff. Let's head back into Scratch and code that step next. Okay, so you might remember that whenever we want our program to be able to respond differently depending on whether a condition is met, and the condition here is if the player's answer equals the correct answer or not, we need to use something called a selection block. And the selection block we're going to use today is the if then else block, and you'll find it under the controls menu here. Now with the selection block, we build a condition in the top portion of the block there. And if that condition is met, if it's true, then the program will run any commands we pop into the top portion of the block there. Else if it's not true, if it hasn't been met, it will run the commands in the bottom portion of the block. Now, just like I've been doing for the other tasks today, I'm going to share with you the commands that I think you're going to need to not only build that condition, but then respond how we want our quiz to, depending whether or not the player's answer was right or not. And I'm going to then hand it over to you to see whether or not you can combine those. So I think we are going to need an operator here, the equals operator, to help us check our player's answer and whether or not it equals the correct answer. So we are going to need our correct answer variable, which we created earlier. Then we want our quiz to be able to respond and say either well done, give an exclamation mark, or that's incorrect. So, have we got all the blocks here? Yes, I think you do. So, okay, so pause me now. See whether or not you can combine those blocks so that when our program is run, it not only generates a question, not only asks a question, but when you respond, if you get the answer right, it says well done. If you get the answer incorrect, it says incorrect. Over to you. Okay, did you manage it? I'm sure you did, but for anyone that needs a bit of additional help, let me show you how I would go about coding this. So our selection block is going to sit under our ask block there. And first thing we need to do is build this condition. So what am I wanting to check here? Well, I want to check whether or not the player's answer is equal to the correct answer. It's as simple as that. And if their answer is equal to the correct answer, I'm going to say well done. Else if it's not, I'm going to say that's incorrect. Okay, let's test it, see if this works. Here we go, going to run the green flag. It's saying what is 2 times 6? 12. If I remember my 2 or 6 times table. Well done, there we go. So one final step in our algorithm, in that this quiz was not supposed to just ask us one question, it was supposed to keep asking us questions over and over forever. It's infinite times tables. So the way we do that is really straightforward. We simply go to the control menu and we get a forever loop and we pop the whole of our code, all of it, into a forever loop, because all of the steps that we've coded there, we want it to just go back to the top and repeat over and over. And now we have got, well done, a times table quiz that will just keep asking us times tables questions for 8:32. I was a bit slow then. Forever! And one final thing I forgot to mention about 5 minutes ago. Yes, of course, if you want to give yourself a more interesting background, of course you can. Simply click bottom right to choose a background. I love the space ones. Where are they? Space City one. There we go. Right, there we go. Infinite times tables in Scratch done. Not only have we recapped our computing knowledge of variables, but we've also created our own times table tester. So finish yours off and have a play to recap your multiplication facts. Enjoy!